Welcome. This is the unit on co-articulation and perception. And we're going to be talking a little bit this week about how you coordinate different kinds of articulatory gestures in time while you're speaking, and what that means for hearing phonological segments or phonetic segments, and maybe also a little bit about how that relates to the patterning of sounds in a language. And this is going to be the last part of our sort of narrow phonetics unit, where we're talking about the minute details of speech sound organization or articulation and perception. And we'll start talking a little bit more about the patterning of sounds in grammar in the next unit. We'll eventually get very abstract and won't be talking so much about articulators and things like that anymore, but this is really foundational for everything that we're going to do in phonology. I want to start out this unit by talking a little bit about voicing and laryngeal distinctions. So remember, this has to do narrowly with whether or not your glottis is vibrating when you're producing speech sounds. But I wanted to think a little bit about the sequence of things that has to happen to form, in this case, a voiceless stop. Right? The first question here on the handout is, what needs to happen in a sequence like ata? Right? Or really maybe ah and any kind of a stop in between two ah vowels. What has to go on? Well, for a coronal stop like ata, there are some steps that your supralaryngeal articulators need to go through. So take a second, pause the video, and think about what needs to happen in the sequence of sounds ah to ah with your supralaryngeal articulators, that is, the ones above the glottis. What needs to happen here is that when you have an ah kind of a vowel, in terms of your tongue, it's not super important what the actual gesture going on with your tongue is, but usually in English, your tongue root's going to be pulled back a little bit to create an ah vowel. Importantly, your tongue body and your tongue front are going to be not close to the roof of your mouth. You're going to have an open vocal tract that allows sound to propagate fairly freely out through your lips, and that's why vowels are loud and sonorous, because they have relatively unconstricted vocal tracts. So mostly above your glottis, your supralaryngeal articulators are going to be making an open vocal tract for a vowel. And then, of course, in a coronal stop like ta, or in any stop, you're completely stopping airflow through the oral cavity. So in English, your tongue tip is going to be up, somewhere here near your alveolar ridge, and it's going to completely block this off in order to stop airflow through the vocal tract. And so what you're going to go from is a relatively open vocal tract. You're going to have to then move your tongue tip up and forward to get to your alveolar ridge here and create a complete occlusion. Presumably that's also going to entail that you're going to change the position of your tongue root and body a little bit, because in order to move the front of the tongue up, you usually have to move the other parts of the tongue as well. So we're going to start with a very open vocal tract with a back and low tongue body, and then we're going to have to move our tongue tip up and forward to contact the alveolar ridge. Right? So that's the first part of what's going to happen. Then eventually, after you've formed your complete contact and completely stopped airflow through the oral cavity, you're eventually going to release this and let your tongue tip come back down, and that creates this transient or burst sound. All right? So that's what's going on in a stop. And if the next vowel is an ah, then you're going to move your tongue back to its original position, probably with the tongue root a little bit back in your pharynx here, tongue body a little bit lower and backer, and your tongue tip is going to have to come down and go back to its original position as well. So you're going to start, again, with your tongue tip low. It's going to need to travel up to your alveolar ridge, and then it's going to need to come back again to a relatively low position in the oral cavity where it's not impeding airflow. So it's a sequence of movements. You have to coordinate this in time. It's a delicate ballet of articulators. That's not the only thing going on, though. If this is a voiceless stop, as we've written it here, we're also going to need to do some things with our glottis, with our larynx, right? And so the next question is, what are the steps that your glottis needs to go through, or your larynx, while you're making this ata sequence? So take a second, pause the video, and think about that. Okay, so what you're going to need to do, vowels in English, like in just about every language, are usually voiced. And what that means is that you're going to need to pull your vocal folds together, close the glottis, and press them together, not super hard, but just hard enough to allow pressure to build up and then push them apart, and then start this voicing cycle that repeats and repeats and repeats. So your vocal folds will be together for that voice sound ta, an ah. And then for the voiceless ta sound, you're then going to need to pull your vocal folds apart in order to allow air to pass unimpeded through the vocal folds so they don't vibrate. That's what a voiceless sound is. And then at some point for that final ah vowel, you're going to need to bring them back together again and let them vibrate because vowels are voiced again. So these are not the only movements that are involved in an ah-ta sequence, but these are the big ones, the major ones that we're going to want to think about, is you're going to have to be doing some things with your tongue tip, or with your tongue more generally, and you're going to have to be doing some things with your glottis. And these two aspects of speech, as we talked about extensively in the acoustics unit, these are largely independent from one another. This is the source, this is part of the filter, and we can manipulate these two aspects of speech almost entirely independently. So that means we're going to have a lot of options for how to coordinate these two kinds of movement in time. And that's what co-articulation is about here. How are we dynamically moving from one vocal tract configuration to another? And in this case, there's at least two degrees of freedom in the vocal tract where are we making all of these movements at exactly the same time? And part of the answer about the difference between different kinds of stops is really going to have to do with the very minute details of the way that this supralaryngeal movement and the laryngeal action are coordinated in time. Right? So we've seen in English that there's several different kinds of phonetic stops that show up. So normally we think about English stops as being voiced and voiceless, and that's, definitely true, or it's a useful way of thinking about phonology. It's often true phonetically. But then we've also seen that in some positions, namely before a stressed vowel or at the beginning of a word, some English stops are also aspirated. So these are going to be three categories of stop consonant, right? Voiced, voiceless unaspirated, and voiceless aspirated. All of them show up in English. And indeed, these are the three most common kinds of stops in the world's languages. Not every language has all of them, but every language has at least one of them. And many languages have more than one of these categories of stops. These are cross-linguistically very common categories. Right? And it turns out that they each can be defined as a particular coordination of these glottal gestures that you're doing and the supralaryngeal gestures. So I'm going to talk about this in between vowels for this unit because it's the easiest way to think about this. Although, of course, you can apply the same kind of reasoning to consonants, say, at the beginning of a sentence or at the beginning of an utterance. It's going to look a little bit different, but the same general principles are going to be there. We're going to talk mostly about consonants in between two vowels because it's a particularly easy way to think about consonant coordination or gestural coordination, and also because it's relevant to the paper I asked you to read for this week, the Fujimura et al. Paper. Okay, so let's think about three broadly distinct timing patterns. So here's one pattern. You just do nothing with your vocal folds. And of course, this is not a voiceless stop anymore. You just keep your vocal folds vibrating and then do whatever you need to do with your tongue tip, and that's going to produce a voiced stop, right? Voicing is going to continue throughout your tongue tip approaching the alveolar ridge. It's going to continue throughout the closure phase of that stop. It's going to continue as you release the stop. It's going to be a fully voiced stop. Right? So that's sort of one pattern. For consonants where you are changing your glottal state, here's two possibilities for how you could do that. You could stop your vocal folds from vibrating, that is, pull them apart, just during the closure phase while your tongue tip is approaching the alveolar ridge and maybe hitting it. You keep your vocal folds apart, but then the second you let that constriction go, you also start your vocal folds vibrating again. You push them back together again. So you time the voicing gesture where you're putting your vocal folds back together to be at the same time as the release of the stop. So what's that going to cause? That's going to cause a voiceless closure phase with voicing that resumes almost immediately upon release, and that's going to be a voiceless unaspirated stop. And if you just tweak that timing pattern a little tiny bit, you'll get another kind of stop here. So again, as you sort of finish with your tongue root gesture for ah, and you start approaching the alveolar ridge with your tongue tip, you pull your vocal folds apart, you stop them from vibrating. So far that's the same as the second category. And you're going to get voicelessness during closure. But then maybe as you press your tongue tip into the alveolar ridge, you release it, release the stop, and you get this burst or this transient. And then maybe you wait 100 milliseconds or 50 milliseconds afterwards until you get your glottis vibrating again. And what's going to happen there is that you're going to end up with a period of voicelessness following the stop release, where air's rushing through the vocal folds because they're not pressed together yet, and that's going to create noise after the stop burst, and that noise is referred to as aspiration. So this is going to be a voiceless aspirated stop. Those are basically the schematic way that we produce these three kinds of stops in English and many other languages, and they correspond to slightly different patterns of gestural timing. How are you going to coordinate the transitions from one segment to another segment? Right? That's what co-articulation refers to. It's this idea that we don't produce each phonological segment or phonetic segment as a discrete unit that lasts some amount of time and then stop everything and then produce the next unit. That's not how speech sounds work. We are always moving on to the next segment while we're in the middle of this one. We end up with articulatory movements that are associated with different segments, sometimes overlapping in time. We get segments bleeding and blending into one another. That's co-articulation. How would we measure these kinds of things, assuming that we don't have some kind of an X-ray machine or like a mid-sagittal cut of a human being that we can observe? How would we try to measure these different timing patterns? In particular, this is going to be partially about acoustics, about how we measure them, say, in Praat, but also how are we going to measure them with our ears, right? How are we going to hear these differences? And one answer that was proposed to this in the 1950s, which has been very, very influential in phonetics and phonology, is the idea of voice onset time, or VOT. And what does that refer to? That's the difference in time between the beginning of voicing, or perhaps the continuation of voicing, in the case of the voice stop, and the stop burst, or the stop release. Right? So if we measure the difference in time between when the stop is released and when voicing begins in the following vowel, that's what VOT, or voice onset time, refers to. And of course, if the voicing continues throughout that consonant closure, as in the voiced stop ada, which is fully voiced, in that case, the voice onset time, we say it's negative, right? Because the voicing actually starts before the burst is even released. Right? And that's obviously going to be true in between two vowels. You can get pre-voicing even in utterance initial position, where the voicing begins before the stop burst. That would also be called negative VOT. It's pretty unusual at the beginnings of utterances in English, although not impossible. Much more normal in Spanish, Russian, French to have pre-voiced or negative VOT voiced stops. Right? In between two vowels, in general, in English, voiced stops will mostly have negative VOT. The second possibility here would be zero VOT, or close to zero VOT, where the stop is released and the voicing resumes almost simultaneously. So this would be the voiceless unaspirated stop, where voicing stops during the stop closure, but then the second you release that stop, you try to begin the voicing again, and it's going to be almost zero VOT in that case. There might be a little bit of a delay. It takes a little bit of time to get your glottis vibrating, but close to zero. It's sometimes referred to as short lag VOT, and that's going to be characteristic of voiceless unaspirated stops. And then finally, for the aspirated stops, where you release the stop, you're going to get this burst in acoustic terms. And then it's going to take some amount of time, depending on how much aspiration the stop has, for your glottis to begin vibrating again. And so that's going to have positive VOT, right? If it takes 40 milliseconds for voicing to start after the stop is released, then we have 40 milliseconds of VOT. Right? So these are three broad categories of stops that we find in a lot of different languages. And acoustically, this VOT measurement is going to be very important for figuring out whether a consonant that we're hearing is voiced, voiceless, or aspirated. We're going to need to pay attention to the time lag between the stop burst or release and the onset of voicing. Right? Whether that time lag is positive or negative, it's going to be an important cue or important thing we need to listen to tell the difference between voiced and voiceless stops. And it's been shown over and over and over again in many languages that if you manipulate the voice onset time of stops, it changes how people perceive them in terms of their voicing and aspirations. This is absolutely a property that human ears use when we listen to language. There's a nice schematic drawing here from a textbook by Peter Ladefoged, shown on the right page of side 1 here. These correspond roughly to the three possibilities we just discussed. These are a little bit different. These diagrams are trying to show you the movement of articulators over time and how they coordinate with one another. So what are we seeing here? This particular example uses labial stops, and so that top tier in A is showing you the supralaryngeal articulators. In this case, it's going to be your two lips. And the idea here is that time goes from left to right, so you start with your lips spread, as in an ah vowel, right? This is going to be an ah-ba sequence. You start with your lips open, ah. You're going to, at some point, move those articulators together. That's where the two lines come together, and it says articulators together in the diagram. So now your two lips are touching each other. That's going to be the closure for ba, ba, right? And then when you release that stop, ba, ba, your lips are coming apart, right? So that's what that top tier of the drawing is trying to show you, the A tier. Right? The B tier here is your vocal folds, or vocal cords as it's written here, and this is trying to show you, are your vocal folds brought together for voicing, or are they pulled apart for voicelessness? And in number 1 here, which is the fully voiced stop, ba, or ba, you can see that they're just together the whole time. So that's sort of a boring tier, and they continue being together and voicing throughout the entire consonant closure. The arrow here pointing downwards is showing you the release of the stop constriction, which is going to correspond roughly to the burst in the acoustic record. And so this one's just going to be fully voiced throughout. And C here, tier C, the bottom one, is trying to show you a rough representation of what this is going to sound like in acoustic terms. So this little dark wavy line that you see in C, that means voicing. Voicing is going to continue acoustically throughout this entire vowel stop vowel sequence. That's a fully voiced stop. VOT negative, because the black arrow here actually comes after the onset of voicing in C. Right? So that's going to be a negative VOT. In diagram 3, which is down the second one down here, we again have in tier A the exact same thing going on with the lips. They start out apart, ah, they come together, and they come apart again, ba. So that's the exact same as in the first one. What's different here, you can see in tier B, the vocal folds start out together for voicing during the vowel, and then you can see they pull apart during the stop closure. And number 3 here, that pulling apart of the vocal folds is timed to be almost exactly the same time as the closure of the two lips. Or in the example we talked about earlier, this would be the closure of the tongue tip and the alveolar ridge. So timing these to be almost exactly the same temporal extent, that's going to result in a voiceless unaspirated stop. And he's written here the normal IPA P symbol, but also this B symbol with a little open dot under it. This open dot diacritic means devoiced. And so sometimes you'll see sentence initial or phrase initial voice stops in English written like this because phonetically they often lack voicing during closure. And they actually have something closer to a zero VOT in English. So you'll sometimes see them described as devoiced voice stops because we think underlyingly or in the phonology they count as voiced, but phonetically the voicing sometimes isn't there. So you can see in tier C, down below number 3 here, that as you pull your vocal folds apart, that little dark wavy voicing line turns into a dashed line, and that means voicelessness in this particular diagram. And so that voicelessness is going to last roughly the duration of the stop closure, and then once the stop is released, the vocal folds come back together at almost exactly the same time, and you end up with voicing resuming immediately after that black arrow, the burst. This is going to be roughly 0 VOT. In number 5 here, on the other hand, you can see that that vocal fold pulling apart kind of a pattern, that sort of big globe in tier B, that lasts longer than in the second picture, and it lasts in particular until after the black arrow indicating consonant release. So now we're going to have positive voice onset time. And what you can see in the acoustic tier and C here, there's that dark wavy line, that's voicing. That stops when you pull your vocal folds apart and you get the skinny dashed line down bottom. That's just voicelessness or probably silence in this particular case. But then after the burst, that black arrow, when your vocal folds are still pulled apart, that's where you're going to find aspiration, and that's indicated here with the thicker and darker dashed line that's overlaid on the voicelessness line. So this is going to be an aspirated stop, or I guess he calls this one strongly aspirated. So this is some ways of thinking about how we coordinate our articulators in time in order to produce sequences of sounds. And it's important, the reason I'm introducing this here is because for these stop voicing distinctions, this is actually telling us something interesting, which is that to know whether a stop is voiced, voiceless, or aspirated, we're going to need to listen to the relative timing of several different things going on, and in particular, the relative timing of acoustic voicing and the burst of a stop is going to tell us a lot about what kind of a stop it is, right? And in particular, paying attention to the release of the stop or the burst of the stop and its position relative to other acoustic landmarks seems to be super important for telling the difference between different kinds of stops. In the cases we've looked at, it's going to be mostly the period between the stop release and the onset of the following vowel. That's going to be really important. And one of the things that means is that if we're trying to tell the difference, trying to understand a language and tell the difference between its sounds, means that laryngeal features like voicing and aspiration, at least on stops, may be easier to hear in some phonetic contexts than they are in others, because it looks like voicing and aspiration in particular depend not only on the things that happen during the stop, but also their relationship to the preceding and following sounds in a phonetic context or position. Right? So this is interesting because it's telling us that understanding or perceiving the difference between these different types of stops might depend on the surrounding sounds in the environment. And if that turns out to make a difference in phonology, then we're going to need to know a little bit about that in order to understand why languages pattern the way they do. And I'll come back to that point at the end of this handout, but then also later in the semester we'll see several patterns that look like they care about these phonetic cues in a particular way.